Hello and welcome to the lesson. This lesson will allow us to solve a question on external division of a line. The coordinates of a point A is 2, 8, 3, and B is -4, -8, -5. A point P divides AB externally in the ratio 7:3. Find the coordinates of P. So let's go to the solution. We're going to use the ratio theorem to solve this question. Let me show you how you use the ratio theorem. We shall obtain the position vectors of A, B, and P. So I will start by drawing a line. So let me draw a line here. Whereby we have A is there, B is there, then point P is there. So P divides AB externally in the ratio 7:3. So let us indicate that ratio. This is how you're supposed to indicate the ratio. So 7 will be that distance. That will be 7. And then -3. -3 is that distance there where we have B. So that will be -3. Then from there, we are getting the position vectors of A, B, and P. So we shall create a center here. We shall have a center. So from P there, we have a center O. So all these vectors to originate from point O. Those are the position vectors. Position vectors are vectors with reference from the origin. So that is OA, OB, OP. Now having that, now we have the position vectors of A, B, and P. Now to obtain the coordinates of P, we would simply be required to get the position of P, the position vector of P, which is OP. Once we get OP, that will give us the coordinate of P. So to get OP, we are going to use the ratio theorem, and this is how we do it. We shall let 7, get this ratio 7 to be M, and then we shall have -3 to be N. So -3 is equals to N. So that will be 7 is equals to M, then -3 is equals to N. So this is now the ratio theorem, that if you want to get OP using the ratio theorem, looking at that diagram there, you get it by M divided by M plus N multiplied by vector OB plus N divided by M plus N multiplied by vector OA. So this is how we get the position vector of P using the ratio theorem. Now, what we have to do now is just substituting M. So therefore, OP is equals to M is 7 divided by M plus N. That is 7 plus -3, that will give 4. Then OB, we shall write OB is we use the column vectors. So from the coordinates of B, we have -4, -8, -5. So write that as a column vector. You get this is -4, -8, and -5, like that. And then plus N. N is -3. Remember that. -3 divided by M plus N. Still that will give us 4. Then the column vector of A, that is OA. We're getting it from here, the coordinates of A. This will give 2, 8, and 3, like that. So from there, we simply need to open the brackets. So 7 divided by 4, multiply by everything, each term that is inside here. So 7 divided by 4, multiply by -4, that will give -7. 7 divided by 4 multiplied by negative 8, that will give negative 14. Then 7 over 4 multiplied by negative 5, that one will have a remainder, so let us give it in form of decimal. This will be negative 8.75, like that. Then plus negative 0 over 4 times 2, that will give negative 1.5, and negative 0 over 4 multiplied by 8, that will give negative 6. Negative 0 over 4 multiplied by 3, that will give negative 9 over 4, which is negative 2.25, like that. So from there, we simply need to subtract. So negative 7 plus negative 1.5, that will be negative 7 minus 1.5, that will be negative 8.5. We go to the second row, negative 14 plus negative 6, that will give negative 20. Then negative 7.5 plus negative 2.25, that will give negative 11. So that is OP. So OP, the column vector of OP is negative 8.5, negative 20, and negative 11. So writing that as coordinate, because we're supposed to write the coordinate of P, will be negative 8.5, negative 20, and negative 11. So that is how you're supposed to solve that question.